Welcome to Praveen Patil, College of Diploma Engineering and Technology. Myself, Raj Ghevari, working as a lecturer in Mechanical Department. We are looking on the subject Theory of Mercy for for the fourth semester. Now, we will be discussing on the remaining topics of Chapter 1, Fundamentals and Types of Mechanism. Now, in this, we will discuss on inversion of double sliding crank chain mechanism, that is of first one, Scotch yoke mechanism. Now, in this mechanism is used for converting rotary motion into reciprocatory motion. This mechanism is obtained by fixing the link 1 or slotted link. So this is the link, this is the part of link 1, this is the part of link 1. This mechanism is obtained by fixing the link 1 or slotted link. Now, link 4 and link 3 act as a sliding. Link 4 and link 3 act as a sliding. So these are the link 4. Let me highlight this. This is a link 4 and this is the link 3rd. Now, so this is the 4th link. This is the 3rd link. So these two link act as a sliding, whereas link 2 is a bar or a crank. So this is a link 2, which can be a bar or a crank, which rotates uniformly about the fixed center O. So this is the fixed center O, which rotates uniformly. Now over here, when the link 2 rotates, the slider slides in slotted link. So what will happen over here is, when this will rotate, so this slider will slides, and the other part, that is the link 4, this one, this part of this, so which reciprocates in a guide bar. So this is a guide bar, it will perform a reciprocates in the guide bar itself. So we can able to understand this mechanism with the help of this second figure. So it is performing, the crank is performing a rotary movement, whereas the slider is performing a sliding movement in the guide bar, and the other part, that is the link 4, is performing a reciprocity movement, that is it is moving in forward as well as it is moving in the backward direction. So this is all about the Scotch yoke mechanism. Now let's discuss on the next type, that is elliptical trammel. Now in this elliptical trammel, this mechanism is used for drawing an ellipse. It is obtained by fixing the link 4, which is slotted frame acting as a crank. Fixing the link 4. Now here the link 4 is nothing but this part. Let me highlight this part. These are the link 4. These are the link 4, which is being fixed. Now the link 1 and link 3 is a slider. So let me show you the links, which is a slider. So this link, first link, this is the first link, that is slider A, and link 3, that is this one, slider B. This link 1 and link 3 is a slider which reciprocates in the slotted frame. So this is a slotted part of frame, this is the slotted part of the frame, so it will reciprocates inside this frame only. So as point on the link 2 can trace out an ellipse or of a semi-major axis. Now over here we can able to observe from this diagram the second part of this diagram. Let me show you the second part of this diagram. So this is the second part of this diagram, and these two sliders, see here, the one slider is performing in this manner. This one slider is sliding in a straight path, that is in this straight manner, whereas the second slider is sliding in this manner. So this is this like second slider. Let me just, first slider's moving in this manner, second slider is moving in this manner, and the elliptical part which has been drawn, the ellipse which is drawn over here. See here, from this point it is been drawn from this point. So this is the path, this is the path of ellipse. So this is how the ellipse has been formed. This is the path of the ellipse which has been drawn out. So this is all about the elliptical trammel. We can also observe this in this part of the diagram. We can also see the working of this elliptical trammel in this part of the diagram much more clearly. Okay, so now let's see about the next type, that is Odom's coupling. So this mechanism is obtained by fixing the link 2. This mechanism is obtained by fixing the link 2, which is acting as a frame. It is used to connect two parallel shafts which are not coaxial. The shaft having axial eccentricity are occupied by using a Odom's coupling. Okay, now the first link, let me say the C part, the first link, the link 1 and link 3 are the two flanks which are rigidly fastened to a shaft by forging, and the link 4 is the central block which is circular disc type having diametrical projections on each face at a right angle to each other, which closely fitted into the slot. So from the second part of this diagram, that is this diagram, we can able to see how this mechanism is being performed. So this red color block, okay, this red color block is the central block which is a circular disc which is through which it is being used to transfer a rotary movement from first shaft to the another shaft. This is the red color block which is placed in between. Okay, this is the part of the red color block which is being placed in between. Okay, so over here from this arrangement we can see how the transmission of the motion from the first shaft is being transferred to the second shaft by using the flanks. First flanks is being meshed with the second flank by using this red color block, and from this third diagram we can clearly able to see how this mechanism is being carried out in the real life. So let's see the advantages. So the driving and the driven shaft rotates at the same speed. Second advantage is there are zero backflaps and torsional stiffness. Compressed to other coupling, it is economical. The replaceable of wear element is inexpensive. Now the applications of this Odom coupling is used in robotics and servo in addition to the printer and copy machine, floor mills. So these are the advantages of the Odom's coupling. So that's all for this chapter. These are the contents of this first chapter. We will stop here. Thank you.